Hi, in this video I hope to discuss a few specially chosen mixed numbers and how to rewrite them as finite decimals. So let's look at what I have. I have 1.5, the mixed number 1.5, which we know is just an abbreviation or a shorthand way of writing 1 plus half. And then what we have here is the proper fraction 1/2. We know from another video is same as the finite decimal 0.5. So I replace that here. So 1 plus half is 1 plus 0.5. And now adding, we know how to add finite decimals. When we add them, we get 1.5. So what we're concluding is 1.5 is same as 1.5. 1.5 is same as 1.5. You might have had this intuition because 1/2 is 0.5. And your intuition is correct. But to justify why 1.5 is 1.5, we do have to go through these steps. It is not correct reasoning to simply say, look at this half and that's half is same as 0.5 and so I'll just replace it by 0.5. We cannot do that because remember this is a notation. 1/2 is part of this notation for mixed number. We can't just pull some part of a notation and replace it by something else. So to make my point, I want you to consider the fraction 20 over 2. Notice this 2 is part of the notation for 20. It's not free to be manipulated, or we cannot do anything with this 2. And if you want to do something with the 2, then you really have to rewrite the numerator as 2 times 10. And then now by the cancellation law of fractions, now you can cancel out the 2's and get your 10. But right now in this step, this 2 is part of the notation for 20. We can't do anything with it. And in that same manner, this 1/2 is part of the notation for 1.5. We can't just pull that apart and put something else instead in its place. We cannot do that. So this is the reasoning for why 1.5 is same as 1.5. Once you understand this reasoning, of course, you can directly go from this step to this step. You can replace 1.5 by 1.5 or 1.5 by 1.5. You can do that. But when pressed for reasoning, these would be the steps. Now, let's look at these two examples that I have. So here I have the mixed number 3 and 6/10. So once again, we rewrite it as 3 plus 6/10. And now this is easy. 6/10 written as a finite decimal is 0.6, and so we get 3.6. The mixed number 3 and 6/10 is exactly same as 3.6. 3.6 is exactly same as 3 and 6/10. And here in a similar manner, I have the mixed number 5, 52 over 100. Proceeding in a very similar manner, we can get 5.52. Or there's also an alternate way we could proceed. We could start out with the mixed number 5, 52 over 100, convert it into an improper fraction, 552 over 100. So here we actually have a decimal fraction, and which we can rewrite it very quickly as a finite decimal, 5.52. So to justify why this mixed number is same as this finite decimal, you could either use this line of reasoning or this line of reasoning. Either way is correct. But it's not okay to say, let's just take this part and put a 0.52 in that. We can't, because 52 over 100 is part of the notation, and so we can't just pull things out of a notation. One more thing I want to point out is the following. Look at this mixed number. This mixed number has a whole number part and a proper fraction part. Similarly, this finite decimal has a whole number part. We call this the integer part. And it has a finite decimal part whose integer part is actually 0. So as you can see, this whole number part and the integer part match up, and this proper fraction part matches up with this finite decimal part where the integer part is 0. So once you understand this reasoning, you can very quickly directly go from here to here or here to here. You could think of 3 and this mixed number 3 and 6/10 as 3.6, and you could view 3.6 as 3/6. Similarly, 5 and 52 hundredths is same as 5.52, or 5.52 can be viewed as the mixed number 5 and 52 over 100. So you could go in back and forth between a mixed number and its equivalent finite decimal part. But when pressed for reasoning as to why they're equal, then you would have to follow either this reasoning or this reasoning and so on.